Okay, so we are going to begin talking about statistical distribution. So we've talked about all the descriptive statistics. We know how to find the mean, the median, and the mode. We know how to do histograms, box and whisker plots, and cumulative frequency graphs, and all those things. So now we're going to talk about probability that's associated with statistics. So when we talk about that, we talk about random variables. We talk about a variable, basically, is something that we're measuring. So a random variable is a number of possible outcomes which could occur when we do something. All right, so you roll a dice. If it's a fair die and it has 6 sides, then there's 6 possible rolls you can get, and that would be your random variable, would be the number of possible rolls. Here's a few other examples, but there's a difference between discrete and continuous. We already talked about this, but discrete, you have possible values of 0, 1, 2, 3, 4. There's no partial values. So a couple of examples they give: number of houses in your suburb which have a power safety switch. So it either has it or it doesn't. There's no other option. You can't have half the switch, it doesn't work. The number of new bicycles sold. You either sell a bicycle or you don't sell the bicycle. You don't sell half the bicycle, or a quarter of the bicycle, or an eighth, or whatever the case might be. So whenever something is either whole or not able to be split, another way of kind of thinking of it, then you have a discrete random variable. And there's a specific discrete random variable distribution that we're going to talk about. The binomial distribution, which we'll talk about a little bit later in another video, is a discrete random variable. And then you have continuous random variables. And continuous random variables are when you're measuring something that can be split or that has a number of possible values. So the examples they give here, the heights of men. So it could be between 50 centimeters and 250 centimeters, but it could be anywhere along that line. You could have a height that's 196.53217 centimeters. So because you can have that, it's continuous. And we're going to look at a particular continuous distribution, and that continuous distribution is the normal distribution. So we're going to look generally at what is a probability distribution and how do you find it, and we'll talk about that. And then we'll talk specifically about 2 binomial distributions, which are discrete, and continuous distributions, which are the normal distribution and the standard normal distribution, but it's still part of the normal distribution. So that's where we're going. We're going to look specifically at binomial and normal, but in order to understand the concept, we're going to sort of just lay the groundwork in this video. So have to understand the difference between discrete and continuous. So here are some examples. So I'm going to get you to pause the video and answer them, and then we'll continue. So hopefully you wrote down your answers. Maybe you didn't listen to me and didn't pause the video, but that's the first one. Says identify the random variable. So the random variable is the amount of rainfall for part A. And it's the height of water. It's the height of water that's collected in a rain gauge. So that's what we're going to use. That's the variable. And it says up to 200 millimeters. So you could have 150, you could have 100, you could have 7. It doesn't really matter. But it couldn't go below 0. You can't have less than 0 because you're measuring height. And then it says indicate whether it's continuous or discrete. So in this case, it's continuous because you're measuring a height, and heights can be split into smaller and smaller values as long as you have a measuring tool that can measure those values. All right, stopping distance of a tire with a new tread pad. You may be wondering why it's spelled T-Y-R-E. This is a book that was put out from Australia, and that's how they spell it. So the stopping distance, again, is going to be a continuous random variable because you could have a variety of stopping distances, and you can pick whatever values you want for the random variable. Again, it has to be, the smallest is 0, but you could have a whole different lengths of stopping distances. And then part C says we're going to just figure out how many times can you switch a switch until it fails. Yeah, you imagine being the guy that just sits there and flicks it on and off and counts them. Great job. But we're just trying to figure out how many times do I flip the switch until it fails. So that's discrete because I either flip it or I don't. I don't have an option of only turning it halfway. You just flick it on and flick it off, flick it on, flick it on, off, and so on. So that's discrete. Okay. So when we're talking about a probability distribution, what we're going to do is we're going to look at all of the different possible ways or outcomes. So all the different possible things that could happen. And then we're going to zero in on one particular thing. So the example that I have up here is when tossing 2 coins, you're looking at the number of heads you can get. So each coin has a head or a tail. So it's possible if you're tossing two of them to get no heads. You could get tail, tail. It's possible to get one head, where you get a head on the first one, a tail on the second one, or the other way around. You get tail and then head. And then it's possible to get two heads, where they're both two heads, right? They're head and head. So then you got to figure, okay, what's the probability distribution for that? Now, you guys are used to hopefully drawing tree diagrams from last year. So you know that if you toss the first coin, right, you could have a head or a tail. And then the second coin could be head or tail. So you can sort of draw the probabilities in on top of that. That's a half, right? And that's a half and a half. And so on. They're all 1/2, assuming it's a fair coin, which is a fair assumption. So if you look at head, head, there's only one way that happens. So two heads is a quarter. And there's only one way that two tails happen, or no heads, so that's also a quarter. But there's two ways. There's a quarter here and a quarter here, so 2 quarters, where you can get a head and a tail. So that's why the probability of getting one head is half, and the probability of getting no heads or 2 heads is a quarter. Okay, and now we can write out a probability distribution table. You could say, you can either draw it like they have there, or you can actually write out a little table where you put x, and then the probability that x is equal to x. You try to do a capital and then a small lowercase, and there's 0, 1, or 2, and the probability is 0.25 first, then 0.5 or 1/2, and then 0.25. Okay, key thing is probability distribution, the probabilities have to add up to 1. We talked about that before. You know that the probability of something happens. So the probability has to add up to 100%, or 1. So if you have the option, in terms of a discrete random variable, of figuring out exactly what possible outcomes there are, you can write it as 0 and 1 and 2 and 3 if it's discrete. But if it's continuous, you may have to do it in terms of ranges. Now, let's look at an example. So here's what the question says. You've got 3 checkout points, A, B, and C, and Consumer Affairs decides to check for the accuracy of the scales. So if it's accurate, they say yes, and if it's not, they say no. Pretty simple. So suppose the random variable is x, and that x stands for the number of accurate weighing scales. So we want to list all the possible outcomes. How many different numbers are there of possible accurate weighing scales? So in order to do that, we typically draw a tree diagram just to kind of give us an idea. So if you look at, I've already got it drawn here just to save us a little bit of time, but checkout A could be yes or no. Then checkout B could be yes or no. And then checkout C could be yes or no. All right, so you get these possibilities. Yes, yes, yes. So there could be 3 yeses. So that's where the 3 comes from. You have yes, yes, no. That's 2. You have yes, no, yes. That's still 2. You also have yes, no, no, which is 1. And then you have no, yes, yes. That's 2 yeses. No, no, yes, which is another 2. Sorry, that's 1. I skipped 1. No, yes, no. But those are both 1. No, no, yes, and no, yes, no. And the last one is no, no, no. So that's where the 0 comes from. So the possible outcomes are 0, 1, 2, or 3. Okay, so then it says describe using X the events of there being one accurate scale. So what's the probability that there's one accurate scale? So we have to look at our table, or sorry, our tree diagram, and try to figure that out. So we're saying there's a 50-50 chance here, and we just add up the distributions. Okay, so if you look at 1/2, I'll just draw this in here. I'm not going to draw it in for all of them, but that's 1/2, that's 1/2, and that's 1/2. They all are 1/2, all the branches. So yes, 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 that's 1/2 times 1/2 times 1/2. So that's 1/8. No, no, no is also 1/2, 1/2, and 1/2. So that's also 1/8. And then all of the branches then, each of these outcomes are 1/8 when you get down to the last ones. So you just have to add up. That's 1/8 total, I'm saying. And then you just have to add up how many of them
are what we want. So if we're looking at one no, or sorry, one yes, then we have no, no, yes. That's one possibility. We have no, yes, no. That's another possibility. And we have yes, no, no. So there's actually 3 possibilities that will give us a 1. With 2, we have yes, yes, no. We have yes, no, yes. And we have no, yes, yes. So those are 3/8 as well. Okay, so there's our probability distribution table. I'm going to continue in a minute, but I'm going to end the video there because it's getting longer than the software will allow. So we'll stop there and we'll keep going next time.